One of the things that I've noticed as I've traveled all over the world on behalf of AAPG is that people everywhere I've gone have been curious about this business of what's happening with this amazing energy revolution, this amazing opportunity that you guys seem to have done in North America with this business of gas shales and unconventional resources. What's that all about? So in the Middle East, where there's an amazing quantity of oil, they want to know. In Southeast Asia, they want to know. So let's talk a little bit about this unconventional resources play and how AAPG can fit into it. The title of my talk is Pushing Hubbert's Curve, Global Implications for the Unconventional Resources Revolution and AAPG's part within that. You guys are all familiar with the fact that M. Keith Hubbert back in 1956 predicted peak oil in North America. He nailed it for 1970, and since then there's been a gradual decline in production. This is a mathematically predictable thing, and it's not surprising, but look how well his experimental curve in blue actually performed relative to the actual production data for North America. Quite remarkable. Now, if you take that assumption and you say that we have a finding phase, a producing phase, and a decline, and you apply that on a more global basis, this is peak production and with the years shown by individual country. Each of these wedges represents a country coming on, going to a maximum, fading and beginning to trail off, or it indicates a new idea being added to that wedge. And we can see that the United States saw its high in around 1970, Europe around 2000, and the Middle East around 2008, give or take. And has the global peak actually occurred around 2006? Now, that's a question at this point. It's up to us to see how far we can push Hubbert's curve further. If we look at the global oil depletion rate, this is a little bit older slide, but it's one of the more recent projections. Everybody would say, based on the Energy Information Agency back in 2004, based on the information they had then, they'd say we're looking at depletion, or for the most part, depletion by about 2060 or so. And this chart shows that if you look up, you can see where 2001 projections were for our production, daily production of oil per day, versus what the 2010 projections were of daily production per day in millions of barrels, which says, oh, those projections from that previous curve were optimistic. So what are we going to do about that? Meanwhile, here's North America's energy portfolio. This is what we anticipate to be consuming. Right now, we're looking at a portfolio that says we might decrease our oil by 3 or 4% between now and 2040, give or take 30 plus years from now. We're going to still need the same amount of oil or more that we use today, and the same for gas. And notice that the biofuels and the renewables are only going to be looking at 13 to 15% of the total portfolio, which means two words for us here in this room: job security. But it also means that we have to come up with new ideas and push things forward. So this concept of the essential ingredient of technology becomes a critical component. Science and technology and new ideas that are brought forward by collaborative work between geologists, engineers, and geophysicists together, working toward solving ever increasingly more difficult problems. So new drilling and completion technologies are the things that we kind of get very excited about. It's big iron, it's lots of money being spent, but oftentimes it's the new ideas that come from places like AAPG and SEG and SPE that drive this. We're all familiar with the phenomenal progress that's occurred geophysically. We're all able now, for very low cost, with incredibly rapid computers, to process information in a completely different way, and the outcome results in tremendous ability to resolve our reservoirs. You're also familiar with the fact that we have very active horizontal drilling technology and hydraulic fracturing technology, yielding a way to expose ourselves to the reservoirs in ways we never could have imagined in the past. And yet, is this really new technology? Is it true that horizontal drilling and hydraulic fracturing are new? No, we've been drilling horizontal wells or long-reach wells for a long time. Have we been doing anything new and different in fracturing? Yes, we're doing different things, but we were fracking back in the 1949, 1950. So these are incremental improvements. Each one is an idea. But the big leaps happen with brand new ideas, and that's what AAPG is completely about. What is that next leap? How do we as geologists manage to reduce risk in some way that we can always have a hole in one? That's our job as geoscientists. And part of that, what we can do with the unconventional world, is to check off a pretty simple geological checklist. Source and maturity. Source, reservoir, trap, and seal. But source and maturity, pore volume, pore size. Those are things we do as geologists every day, and they drive what works and doesn't work in unconventional resources. Pressure, we can address that, as well as viscosity. That understanding, that maturity drives that. And these are the things that control success or failure in an unconventional play in North America or elsewhere in the world. Now here's a slide I borrowed from the EIA, and I've liberally put stuff across the top of it. What you can see are the unconventional plays underneath the conventional ones. And you'll notice that I'm showing a play that up there that goes down gradually to water, one that has a water leg, one that's trapping against a fault, one that's trapping against lateral stratigraphic variability. There is no resource play magic. It's geological principles of source, reservoir, trap, and seal that apply across the board in these systems. Therefore, geology and geophysics have ongoing relevance to a spectacular economic revolution within what we're doing. We're used to a conventional rock being like this, where the individual grains are about the size of a poppy seed. We can imagine that. And we can imagine them being stacked together in a cube that's about the thickness of a penny. That's what that is. That's a conventional reservoir. An unconventional reservoir can look quite a lot like that. The porosity systems that you can see on the right are quite a lot like the porosity system on the left in that little sandstone. But the difference is 100 times difference in magnification. This is 15 microns. Well, what's 15 microns? 15 microns means that I can put 10 of those cubes this way and 10 of those cubes this way across the cross-section of one of my scruffy little hairs. Now, I'm not going to spare one of those because I've only got 2 or 3 left. But the bottom line is that if I pluck that hair out and put it in a scanning electron microscope, these pores would be grossly dwarfed. These are really, really, really small pores, down to the point where individual molecules of gas have trouble squeezing through those little holes. And yet still in this rock that we consider to be source rock, in this rock that we consider to be background stuff that always gave shows, but has good fluorescence and has good cut and is full of oil, we have tremendous production. And you guys are familiar with the Bakken story, and what we've seen there is a phenomenal impact of drilling, an incredible use of the land, and tremendous production, but at great price. Look how many horizontal wells have been drilled there. Imagine how much it costs to drill each of those wells. On average, you're looking at an economic hurdle, depending on the company and where they are in the play, of anywhere from $35 up to $70+ as their break-even price. It's not cheap. The margins can be slim. But the good news is that in North America, which was blessed in its early days with great conventional resources, we've now scraped down to the bottom of the bucket and gotten into things that are very, very tight, but there's a lot of it out there. And so that gives us a lot of places to play. It's a wonderful sandbox to play. Come out and play with us would be the response. But we've also got the question in realizing energy potential in North America and in the rest of the world of what the public policy and public perceptions are. We have to be honest and direct with what we're seeing, and there's information that has to be addressed. I'll give you a quick, interesting statistic. Did you know, I think most of you know, that about 60% of the people in North America are avidly against fracking? I wonder if you knew that about 65 to 70% of the people in the United States think that hydraulic fracturing for the purposes of enhanced recovery and enhancing hydrocarbon production in the United States, 60 to 70% think that's a great thing. So simply what we call it matters. Fracking sounds nasty to some people. I don't know why. But the other component is that we've got policy. And that policy is going to require us to push forward domestic exploration and production. And it's also going to require us to look at a strategic fuel for the future of North America, which is, in our case, gas. Now, that gas, in a lot of places, has resulted in people being very concerned. And that diagram on the left with the drinking water glass is what a lot of our friends in North America and elsewhere in the world believe is the way we do our business. We go down there, we frack it about 6 inches deep under the ground, and it all comes straight up to the surface, and all those nasty chemicals come merging in with their drinking water. That's what they're afraid of, and we're not providing the right information. So let's talk about just kind of an example. Here's a well out in the DJ Basin in the middle of a town. Are they worried about fracking? You bet they are. But let's talk about scale. That same photograph, this photograph right here, put roughly to scale, is that little bitty box way up there. The blue that you see is a drinking water supply for the nation and for pretty much across the area. And all the way below it is a bunch of impervious rock full of salt water and tight impervious rock. And way down at the bottom is where we're drilling for our oil-bearing rock. Now, by the way, the little yellow marks are the hydraulic fractures, and I will emphasize the fact that up there at the top, that drill rig is 10 times bigger in that diagram than it actually is to scale, and those fracks are 10 times taller than they actually are to scale. So scale matters, and we are responsible for helping inform our friends and neighbors and populace of how that works. So let's talk about the unconventional tight oil plays. We've learned some lessons by drilling a lot of these things. One is that 2 of the plays represent 81% of the total. The same sort of 80-20 rule applies in almost every basin we've gone. This is a lesson potentially for the rest of the world. But those 2 or 3 or 4 plays in any given basin that work really well can have a tremendous impact. And look at the remarkable increase in production on a daily basis as a function of the Eagle Ford and the Bakken and a bunch of the other plays. In gas, we're looking at a situation where gas tends to have a few more hero plays, a few more successes. So in any given basin, several plays might work. And now today we can actually say that 40% of the production of the United States, or the consumption of gas in the United States, comes from these plays. What a remarkable accomplishment on the part of our industry to prove direct relevance of what geoscience can do on behalf of a country. But as they scratched here on this rock, it runs out fast. The decline curves are very, very steep in tight wells, and you can see the dark curve plummeting down and going out versus the long, slow production of a conventional well. That has implications in a bigger picture too. If we start lumping whole plays together, we can start to think in terms of the shale oil wedge coming up to a maximum, and what happens on Hubbard's curve? It comes back down the other side, and back down the other side is typically steeper. Why? Because 1, these wells decline really quickly, and 2, you get to an economic limit of what is and isn't working, and that plummets off quickly. So that shale oil wedge, what's it look like if we stretch it out over time and throw in all those extra plays? There's the wedge getting fat with tight shale and tight oil and slowly tapering off. That looks a little depressing, but let's remember, look at the 2010 level. Look out at 2040. We're still producing as much or more oil in 2040 as we were in 2010. That's good news. Now, what about tight oil production relative to peak oil? There's our peak oil curve back in 1970. Look at that long decline of the dark brown, but the light brown popping up. That's the impact we're going to do. Have we completely turned around Hubbard's curve? No. We put a hump out onto the side of it, and we should anticipate a gradual decline thereafter. But that hump, what's it do relative to energy independence? We hear about this. Energy independence. We can start exporting oil. There's no problem. We're looking at about a 5 million barrel per day deficit at this point in time. There's going to be a time when we might break that, but that's where we are today, depending on new ideas, and that's what AAPG is all about. What about natural gas? Natural gas supply is considerably more optimistic. The dotted line is U.S. domestic consumption projected forward. Look at that gas supply going out well off into the future. Tremendous increase, 55% increase in production by 2040. Well, what's the effect been on a price? You guys have seen it here if you're gas producers. Look at the price of the United States in black. Black is U.S. gas price. It's complete parity with Asia and Europe until the Barnett and the other gas resource plays kicked in. Look at the differentiation of the dollars then per MCF, $3 to $4 an MCF, maybe 5 or 6 on a really good day, versus in Asia, in Japan today, where they're paying $19 to $20 per MCF. We are so good that we've lowered our own prices. That's part of what we have to deal with as we go forward. The other part that we have to take into account as we look forward into this is the fact that we're going to be spending a lot of money. The money that we're going to have to spend, if we want to see that gas impact, we're going to have to move toward investing on the order of 77% more drilling on a per annum basis over 2010, and keep doing it. And out toward the out years, 2035, 2040, we have to increase that rate of investment. Tremendous dollars involved. So what's that mean relative to global unconventional gas and oil opportunities? There are basins all over the world. There's a remarkable opportunity throughout all of Russia, the Middle East, India, China. Tremendous opportunities, and a lot's happening down in Latin America already. On a global basis, we're looking at more than 400 shale wells being drilled outside of North America in 2014. Their new rigs are popping up everywhere. In the UK, they've lifted the moratorium on hydraulic fracturing. I saw an April Fool's Day image of a horizontal well drilling in the Queen's backyard at Buckingham Palace. But it speaks to the fact that things are changing on a global basis. There are huge estimates of resources in China, Australia, Poland, and so on. The question, and it's always the question with what we do in oil and gas, is where are the hero plays going to be and where are the goats going to be? Well, this is where the hero play is supposed to be, China. Let's have a quick look at China. The Middle East isn't included because there's so much gas in Qatar. However, in Saudi Arabia, there is a significant shale gas opportunity, and they are actively pursuing it there, and they're going to find a lot, I'm sure. But let's look at China. I just came back from an opportunity to go to a conference where the Chinese are very aggressively looking at unconventional resources. Those major basins across China are quite spectacular in their character. They have huge resources of very organic rich shale, both in the form of lacustrine shale and marine shale. But the problem is that they've run into is that it's a Goldilocks situation. On your right, or on your left, excuse me, in North America, we've got a lot of basins that have been cooked not too hot, not too cold, but just right. In China, they've got a bunch of basins that are cooked way too hot and not nearly enough, and not nearly enough of those basins have just right conditions. And so they've got a much greater challenge, and AAPG and other organizations will be working with the Chinese, and they have brilliant researchers there. We're going to be working to try and solve that. But this is what the impact is. All that glitters not gold. That big circle that was drawn there, China, the biggest shale gas resource in the world, tremendous organic carbon in the ground, but getting it out has resulted in them having to, and the attempts to get it out have resulted in them having to greatly lower their investment. So that comes back to that Wallace Pratt quote that Steve mentioned, and that is, oil is first found in the mines, and he said of the mines of men, but first oil is found in the minds of men and women everywhere who embrace good geoscience, and that's what AAPG is about. Our job is to push this forward. We need new, not only incremental ideas, but we need new ideas. So here's Kilo, my horse, and he and I are both in agreement. The game here for all of us, the challenge here for all of us in AAPG is to make the leap, find a way to get over the hump, and push Hubbard's curve forward with brand new ideas. And that's what AAPG does in such great abundance, in such tremendous capability. So thank you very much, and we'll hand this back over.